This example is going to show you how to find the center of mass of an object. Now in this example, we're only going to find the center of mass, or the x-coordinate of the center of mass, because that's all we're going to deal with. But if you were given x and y and even x, y, and z coordinates for an object, you could do exactly the same thing. You just have to do it 3 times, and then you'd have the 3 coordinates of the center of mass. So for part A here, we have 2 objects that have the same mass. M1 is 3 kilograms, and M2 is also 3 kilograms. And in this first part, the x-coordinate of this object is x equals 2 meters, and the x-coordinate of the second mass is 8 meters. So if I just drew, a simple number line here, 1, 2, 3, 4, 5, 6, 7, 8, right? X1 is here, X2 is here. So it's always good to kind of have a guess. You should be used to doing this. Since the masses are the same, the center of mass should be somewhere in the middle of this. So right here, x equals 5. I mean, we can actually even do this without any math here. At x equals 5, we're 3 away from this guy, and we're also 3 away from this guy. But let's show how the mass works, okay? So to find the center of mass, or the x-coordinate of the center of mass, or however you want to do it, I think your book even says x sub cm, okay? So first we take the mass of x1 and divide that by the total mass, right? So capital M is equal to all of the M1 plus M2 plus ... however many masses we have, okay? And then we multiply this fraction, right? It's really how much of the system is M1 by that actual coordinate. Then we add M2 over M times that x coordinate, right? And we could do this for as many objects as I have, okay? Up until, however many there are. So that's for the first object, 3 kilograms over a total of 6, okay? M1 is 3 kilograms. Let's write this out. Big M equals M1 plus M2. That's equal to 6 kilograms. So let's be explicit about where I'm getting those numbers, okay? Times the x-coordinate of that first mass is 2 meters, okay? Plus, now, M2 is also 3 kilograms. Big M is still 6 kilograms, okay? So I know I'm writing... it doesn't really need a parentheses. I know I'm writing a lot of the same numbers, but I want to make sure you know where I'm pulling them from. Here's my still 6 kilograms, right? This here, let's do a different color. This is M1 over M. This is M2 over M, right? Then we have this x-coordinate was 8 meters, okay? So think of these fractions as like how much of the center of mass depends on that one object. Now, in this case, same mass, so they contribute the same. But you'll see in the next part of this that these fractions will be very different and what that will mean. So as you see, the kilograms cancel out and our unit is meters, and we get 5 meters, right? X equals 5 meters. And that's exactly what we figured out over here. The masses are the same. The center of mass is halfway in between them. So this was an easy example here. Let's do part B of this, where we have M1 is 3 kilograms. It's at where it was before, 2 meters. But now our second mass is 33 kilograms, right? And it's at X2 equals 8 meters, just like before. So here's our number line. 1, 2, 3, 4, 5, 6, 7, 8, obviously not to scale, right? Here's my 8, here's my 2, here's my 3 kilogram mass, but at 8 here, I've got a 33 kilogram mass. So again, this is not to scale, but I've got a much heavier object here. So your gut should tell you, first of all, we can say with certainty that the center of mass is between 2 and 8, right? It's definitely not this way, and it's definitely not this way. It's still between these two. But at this point, sorry, I shouldn't have put a mark there. But at this point, hopefully you're starting to think it's definitely closer to 8 than it is to 2, all right? So in our head, we can have a good idea of where this center of mass is. So the x component of the center of mass is M1 over M. Oh, and let's do this explicitly. Big M is 36 kilograms. Little M1 plus M2, right? Times X1 plus M2 over big M times X2, plus dot, 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 as many masses as we have. We only have one in this scenario. So now we've got M1 is 3 kilograms over 33 kilograms times 2 meters plus 33 over 36. Oops, I forgot my kilograms. Times 8 meters. So let's look at these fractions again. Remember, these fractions tell us how much each object contributes to this center of mass. And you can see that M1 here only contributes 1/11, okay, to the center of mass. And that means M2 will contribute 10, more than that, should I say, okay? So here's some numerical verification that we're going to be closer to 8 than we are to 2. I'm going to go ahead and let you guys do the math. Oops, I'm sorry, this should be 36. My bad. 3 over 36, because remember this mass is 36. Okay, if you caught that, good for you, if you've been yelling at your computer. I'll let you guys do the plug and chug, but we get X center of mass is equal to 7.5 meters. So this is, in fact, still between 2 and 8. Okay, there's no way you could do this that you would be this way over, okay, or on the other side of 2. Excuse me. But we're definitely much closer to 8 than we were to the 2, and that's because our M2 is so much bigger. So you'll do more examples like this with center of mass, but this should give you a good start.